So welcome back for the second lecture of this week. So we had started our discussions on syntax. So yes, so in the last lecture we had talked about what is the formalism for doing the syntax parsing. So we had talked about context-free grammars. Now we will see how do we use context-free grammars for the actual parsing. So let us take a simple grammar in terms of in a CFG formalism. So you are in the grammar it is said that a sentence can be a noun phrase followed by a verb phrase, or an auxiliary followed by a noun phrase followed by a verb phrase, or a single verb phrase. Noun phrase can be a determiner followed by a nominal. Nominal can be a noun, and so on. So all the various possibilities are shown here. And similarly, these are all the pre-terminals that are giving me terminals, that are words in my lexicon. So this is one such grammar. And now, using this grammar, I can write various sentences. Okay. So for example, I want to write the sentence, the man read this book. Okay. So I want to write this sentence, the man read this book. Now how do what kind of rules in the grammar do I use so that I can generate the sentence? So I have to write the man read this book. Okay. So let me just do it quickly on the paper. Now the sentence can be a noun phrase followed by a verb phrase, or an auxiliary followed by a noun phrase, verb phrase, or a verb phrase. In this case, it does not start with an auxiliary nor a verb. So it has to be a noun phrase followed by a verb phrase. So I have to first start by a noun phrase followed by a verb phrase. Okay, and I'll assume that the man will come in noun phrase and read this book will come in verb phrase. So what will be the next derivation? From NP I have to get the man. So I have to get something that says determiner nominal. Okay. So here I will say determiner nominal and verb phrase. Okay. And determiner can give me the, and nominal can give me noun, which can give me the word man. Okay. So in some steps I can determiner to the nominal verb phrase, the noun verb phrase. Okay. And if I want to complete this, I will say the man verb phrase. Now the verb phrase I have to derive read this book. Okay. So verb phrase goes to verb and noun phrase. Is there something like that? Yes. Verb phrase goes to verb and noun phrase. So I will use this and say the man, verb, noun phrase. Verb can directly give me read. The man read noun phrase, and from noun phrase I have to derive this book. So I have to again write this determiner followed by a nominal. This will become a determiner. The man read determiner nominal, and this will give me this. This will give me noun, and this will give me book. Okay, and that will give me the whole sentence. The man read this book. That's how I derive a sentence using this grammar. So now, once I have this derivation, I can use this derivation to denote what is the particular syntax tree that underlies the sentence as per this grammar. Okay. So same derivation can be used to show the parse tree. So this is my derivation, and this derivation can be shown using this parse tree. Because from sentence you derived NP VP. From NP you derive determiner nominal, VP verb noun phrase, and to this particular subtree. Okay. So this is exactly what was the derivation that you did for the sentence in my grammar. So that can immediately tell me what is the problem of parsing. I am given the grammar and I am given the sentence in my language. So given the sentence and my grammar, I want to find out what is its actual parse tree. And there may not be a unique parse tree, there can be multiple parse tree. So the process of parsing is to find out all the possible parse trees for a given sentence as per my grammar. So find out all trees whose root is the start symbol S, okay, because I have to start with the start variable in my context free grammar, and which cover exactly the words in the input. Okay. Now what are the constraints on which I have to do the parsing? Suppose my sentence is book that flight. So what are the constraints? In my parse, there should be 3 leaf nodes: book, that, and flight. And I must start at the start node. And then I have to explore all the possible rules such that I come up with a tree starting with S as the root node and book that flight as the only 3 leaf nodes. Okay. So yes, the tree must have one root, start symbol S, and that tells me that I can explore it in at least 2 different ways. One is I can do it top down. Start from S, try to find out all the possible trees I'm finding out I can have as per my grammar, and see if there is one tree that can give me only the leaf nodes. Book that flight. This is top down. Other approach is bottom up. I start from book that flight, go upwards, what are the non-terminals, and then see if any of this combination can lead to a full tree starting from S. Okay, so these are 2 different strategies, and that's what we will discuss. How do we use a top down or a bottom up approach for parsing given this grammar? So let's take this grammar. Okay, so you have certain rules. So left hand side is mainly the rules for non-terminals and pre-terminals, and right hand side are for the lexicon, pre-terminals deriving the terminals. Okay. Now using this grammar, you want to find out a parse for book that flight, and we will use both the top down and bottom up strategies for finding out this parse tree. So yeah, this is also what is the expected parse tree. Book that flight, this is a whole verb phrase starting from a verb and a noun phrase. So book is a verb and that flight is a noun phrase. Okay, so I want to come up with this parse tree given the grammar. And how do I do that in a deterministic manner using my top down strategy. So how do I start? So I have to start from my start node, root node in top down, and using my grammar, as for my grammar I will see what are the different possible rules I can apply at this point. Keep on going downwards. Okay, so start by assuming that the input can be derived by S, then find out the trees that start with S, looking at the rules that are having S on the left hand side, because what are all the different things that S can derive. Now when you are going downward in your tree, once you obtain the part of speech category, you will see if that matches the word in the leaf nodes. If it is not matching, you will go back and try out some other path. Okay. And if there is any tree where the part of speech categories are not matching the words at the leaf nodes, you will reject that tree. Okay. So let us see. So I am starting with S. Okay. Now what is my first rule? So what are the different rules from S? So first rule says S can go to NPVP. So what I will do, I will try to explore that path. S can go to NPVP. Now from NP, what is the next possible rule? So next rule from NP is NP can give me a pronoun. Okay, NP gave me a pronoun. Again I will try to explore this further. Will pronoun give me so pronoun will be the first word. Now pronoun is a pre-terminal. Now what is the first pre-terminal? Book. So pronoun can never give me a book. Book is not a pronoun. So this path is not correct. So I will go back. From NP I will try to explore some other path. Okay. So NP can also give me a proper noun. So you see, these are the rules in sequence in my grammar. NP can give me a pronoun, NP can give me a proper noun. So again, proper noun is a pre-terminal that cannot give me book. So again, I cannot accept this path. So I'll go back. Next rule is NP gives me determiner followed by a nominal. Okay. So again, the first word has to be a determiner that in the sentence, but the first word is book. That is not a determiner. Okay. So again, this path is not correct. Now we see in the grammar, there is no other rule that has NP on the left hand side. Okay. So that means I have to now go back to the initial assumption that S will derive NP-VP. So I have to try out the next possibility. Then as per my grammar, the next possibility is S can give me auxiliary followed by noun phrase followed by a verb phrase. So okay, let me do that. So yes, S is giving me auxiliary, noun phrase and verb phrase. Again, what is auxiliary? Auxiliary is a pre-terminal and that gives only does. It does not give me book. Okay. So again, this path is not correct. And auxiliary cannot give me anything else. So I have to again go back and try out something else from S. And the only remaining thing is VP. So S gives me a VP. Okay. Now I will go to my grammar. What are the rules from VP? VP can give me a verb. That is the first thing. VP gives me a verb. Okay, good. Now, verb also gives me book. That match is there. But what happens to the other two words in my sentence? That flight. Verb gives me book, but that flight is not covered in this tree. So this is not a valid tree. Yes, that flight, there is no other, no node starting from S that captures this. This is again not a valid tree. So I'll try out something else with VP. So next possibility is verb followed by NP. Okay, verb followed by NP. And verb gives me book. Well, now from NP, I have to get that flight. Now again from NP I can get pronoun. Pronoun cannot give me that. Yes. Then I can get proper noun. It will also not give me that. Then I can, from NP I can get determiner followed by nominal. Okay. And that is a determiner. And from nominal I can go to noun and this can give me flight. So that means by doing all this exploration systematically, I can come up with a parse tree that starts from S and exactly covers these leaf nodes, book that flight in my input. So that is my top-down parsing strategy. Okay, so hope that is clear. So you are given all the rules, you start from S and try to explore in some order. You can take it, you can try to explore in the same order that is in which they are given to you. Okay, you might try to put them in the order in which they are actually used in language. So which one is more probable than other? That is also okay. But again, but you see that this requires a far too many steps, right? So you are exploring paths that will probably never lead to the whole parse tree. So this means there is certain wastage of space. So we will try to take that problem, that how we can avoid that. This was my top-down parsing. Now, what do I do in bottom-up parsing? In top-up, I start with S. In bottom-up, I will start with my leaf nodes. I will start with book that flight, and I will try to grow my tree upwards and see which one can give me a complete tree starting from S. Okay. So the parser starts with the words of the input and tries to build trees from the words up by applying rules from the grammar, one at a time. And parser looks for the places in the parse in progress where the right hand side of the rule might fit. Okay. In top-down, we were looking at always the left hand side. If the current non-terminal is, what is the rule in the left hand side? So that accordingly I am trying to generate the right hand side. Here I am seeing what in the right hand side I already have. Accordingly I select a rule in my grammar. So let's do this bottom-up parsing. So I have the sentence book that flight. I will start by seeing what are the nodes in my grammar that can generate this. Okay. So I start by say book, and the first rule that derives book is noun. Okay. Then I go up to noun and say nominal gives me noun, fine, and nominal can gives me nominal followed by a noun. So I am growing my T upward, but now I arrive at noun that is a preterminal, and noun will not give me that. Okay, so that is not a noun. So this is an inconsistency. So I have to go back and see, okay, what is the next possible rule from nominal. So I have to derive from nominal, nominal followed by PP. So remember again, we are seeing in which rule this occurs in the right hand side. Okay, and accordingly I will take the projection. Nominal gives me nominal followed by PP. Now can PP give me that flight? So from PP, so from that I try to grow it upwards. I see determiner. Determiner comes in right hand side of this rule, and P gives me determiner nominal. And flight, again I grow it upwards, it gives me noun, and nominal can give me noun. Okay, so this looks a nice tree. But now can I attach PP to NP? So yes, if I grow NP upwards, I will say okay, S can give me NP followed by VP. This creates a problem in that this verb phrase does not have any children, so it cannot take me to any leaf node. Okay, so this is not valid. If I go to this part, can PP attach to determiner and NP? Again, there is no rule in my grammar that PP can be a determiner followed by NP. So I have to go back again. Try some other path where verb is in the right hand side. VP, yes, S, and determiner noun phrase, what can they give? To give me S? Again, this does not work out. So I try out something else with VP. So I say VP gives me VP followed by a prepositional phrase. Again, prepositional phrase does not give me determiner followed by a noun phrase. This will not work out again. Go one step down. So earlier I was saying VP is deriving verb. Now I am saying okay, VP derives verb followed by a NP. Does that work? Yes, if I can attach this VP to this verb and this noun phrase. Okay, and then I can say that S can derive this VP, and this gives me the whole parse tree. So this is my bottom-up strategy. I start with the words in the leaves, try to grow them upwards by seeing what is the rule in my grammar where this occurs in the right hand side. Similarly, I will see here and so on. And finally, can I build them as a single tree starting from S? And that strategy finally gives me this particular tree. So if we just try to compare this top-down versus bottom-up approaches, so what do we see? So what we were seeing in top-down, we were always seeing wherever this non-terminal appears in the left-hand side, and I immediately do the prediction. So what happens that I can always explore options that will never lead to the full pass. Okay, I can always find options that will only give me one word. But so all the options were giving me a pass starting from S in the top-down strategy. But it might happen that some options are giving me a particular parse tree where all the words are not covered or some extra words are covered. Okay, so this actual connection to the actual sentence is not taken care. So in the bottom up, it is the other way around. So you are always seeing the words first, so you are exploring those parts that are covering the whole sentence. But it might happen that the pass that you come up with is not a complete pass because it is not having a root at S. Okay, so there may not be a full pass. And there are wastage spaces in both top down and bottom up. Okay, so you are seeing you are exploring many paths that are probably not relevant, and this depends on branching of my grammar in either direction. Okay, so to avoid this problem and obtain an algorithm that works in polynomial time, so we will use some dynamic programming approach. Okay, so we have been using dynamic programming a lot in this course. So we use that for added distance, then we use that for perturbative decoding kind of algorithm. Now we will see how to use that for obtaining an efficient parsing algorithm. So idea is that can we cache some intermediate results instead of exploring all the different possibilities that are not relevant. So by doing this caching, I can obtain a polynomial time parsing algorithm for context-free grammars. Okay, and there are different dynamic programming algorithms that are both top-down as well as bottom-up, and they can work in roughly order of n cube time, where n is the length of the sentence, number of words in my input string. So what are the different approaches for dynamic programming parsing? So one very popular algorithm is CKY algorithm that works in bottom-up manner. Okay, so you will do it for individual words, then you are going to the sequence of 2 words and so on up to you go to the whole sentence. And so the only thing is that it requires some normalization of the grammar, that we will also see what is that normalization. Then there is early parser, that is again very popular, that works in top-down manner. It does not require any normalization of the grammar and slightly more complex than the CKY algorithm. And a generic framework is something called a chart parser, where for individual phrases in the sentence, they will see what are the possible trees they will retain in the chart and use that for the higher level trees. Okay. So and they combine both of these approaches, bottom up and top down. So we will only focus on CKY algorithm, that how do we use this for finding out parse in an efficient polynomial time. Okay. So how does this CKY algorithm works? Now before that we have seen that this requires normalization of grammar. So what is that? So to apply CKY algorithm, so my grammar must be converted to a normal form called Chomsky normal form. Okay. And what is the constraint in Chomsky normal form? So the constraint is that all the prediction of my grammar should be having one of these 2 forms. That is either exactly 2 non-terminals on the right hand side or 1 terminal symbol on the right hand side. So what do I mean by that? In the context-free grammars, a rule is of the form A goes to gamma, where A is a non-terminal and gamma can be a sequence of terminals and non-terminals. This is general CFG prediction rule. So what happens in the case of Chomsky normal form? The rules are constrained to be of these 2 forms. A goes to B, C, all these are non-terminals, or A goes to small a. Small a is a terminal. So left hand side is always the same, it is only 1 non-terminal. In Chomsky normal form, what happens is that you put some constraints on the right hand side. So it can have either only 2 non-terminals or only 1 terminal. So to apply CKY algorithm, I must convert my grammar in any generic context-free grammar form to Chomsky normal form. Okay. So what are the steps involved? There are certain steps, but we will see what are necessary for our case. So we will also see that how do we store all the possible phrases, what are their parsage in a triangular table in the CKY algorithm. So let me quickly show how we convert a grammar to Chomsky normal form. So on the left hand side you have a grammar, okay, and I want to convert it to Chomsky normal form. So can you quickly go through the grammar and find out the rules that are not in Chomsky normal form? So all these are 1 non-terminal giving me a 1 terminal, yes, in all these cases. So they are pre-terminal to terminal. They are always in Chomsky normal form, yes, a non-terminal giving me a single terminal. Now let me go upwards. So PP gives me preposition followed by a noun phrase. Again 1 non-terminal giving me 2 non-terminals in CNF. This is also in CNF, this is also CNF, but this rule is not in CNF. VP goes to verb. 1 non-terminal giving me another non-terminal. So how do I actually convert this to Chomsky normal form? So the idea would be, I will find out what are the terminals that this derives. So verb derives book, include and prefer. So instead of this rule, I'll add a new rule. Verb phrase gives me book, include and prefer. Okay, and this is the strategy. Similarly here, this is in CNF, this is in CNF. What about this rule? Nominal goes to noun. Again, I'll find out what are different things that noun derives. Book, flight, meal and money, and I'll add a rule. Nominal derives book, flight, meal and money. This is in CNF. So here again NP goes to pronoun. I'll find out pronoun goes to I, he, she, me. So NP gives me I, he, she, me. As goes to VP is again not in CNF. So VP gives me verb and also verb NP. Okay, so I have to add these rules. As goes to verb NP, as goes to VP NP, as goes to prepositional NP. Okay, plus for VP going to verb, I have to now take its next rule. Verb going to book, include, prefer, and the rule I will add is as goes to book, include and prefer. As going to NP, VP is fine, but what do I do with this rule? As goes to auxiliary NP and VP. Okay, so for this kind of rule, as goes to auxiliary NP, VP, where a single non-terminal derives 3 non-terminals. So what do? I coin some new non-terminal. So I will say that auxiliary and noun phrase together make a new non-terminal, say x1. Okay, so what will be my grammar? It will be x goes to x1 followed by VP, and x1 will be auxiliary followed by NP, and this is equivalent to this rule. And now this is in my Chomsky normal form. So idea is that whenever you have a rule where you have more than 2 non-terminals, you try to break them down such that it is one non-terminal, another non-terminal. This you can again further break down if needed. Okay, and this is a simple approach. And if you have a rule like this, A goes to B and B goes to C, you take this to A goes to small c. This is a terminal. Okay, and also if B has something else, you would take care of everything in this. Yes, that's what we saw in this particular example. So now, if I convert this original grammar to Chomsky normal form, this is how it will look like. Okay, so you see that here as goes to VP now has multiple rules. As goes to verb NP, as goes to VP NP, and as goes to book, include, prefer, and so on for the other cases. So in this lecture we had seen that how do we do a simple parsing using top-down approach and bottom-up approach, but they are not very efficient. So can we do something better by using dynamic programming parsing approach? And for that we will be seeing CKY algorithm. So how do you use CKY algorithm for an efficient parsing? But CKY algorithm requires normalization to some Chomsky normal form, and we saw how do you convert the grammar to Chomsky normal form. So in the next lecture we will start with the Chomsky normal form and see, given a string, how do we parse it using CKY algorithm.